at a couple of examples. This first one, I think actually both of them are taken from old AP exams.
They're still working on this thing?
Yeah.
I saw it inside of it and I was like, man, you really can't fit 3 people inside of it.
Oh, when it was open? Yeah.
You glanced at it? Yeah, I walked from here, you can see it. It's like right open. It's
Th-
huge.
There's a great big open area in there.
There's like 3 small things in there. It's like a big open space. I wonder why it's so big then.
It's massive.
Don't know. All right. So let's take a look at this one about moose population. So a study was conducted to determine where moose are found in a region containing a large burned area. A map of the study area was partitioned into the 4 following habitat types. One is inside the burned area, but not near the edge of the burned area. 2 is inside the burned area, near the edge. 3 is outside the burned area, also near the edge of the burned area. And 4 is the area outside the burned area, not near the edge.
What?
That's
Okay, so you see this solid line?
yes.
Everything inside the solid line was burned. 1 is inside the burned area, but not near the edge of the burned area. 2 is inside the burned area, but it's near the edge.
That makes sense.
3 is not inside the burned area, but it's near the edge. And 4 is outside the burned area, but not near the edge. And it says figure not drawn to scale. So the total acreage in each of the habitat types was determined for the study area. Using an aerial survey, moose locations were observed and classified into one of the 4 habitat types. The results are given in the table below. The proportion of total acreage in each of the habitat types was determined for the study area. Oh yeah, it says that again. Forgot that.
That's the same thing.
Yeah, that was my accident when I was cutting and pasting this into here. So we have the 4 habitat types, we have the proportion of the total acreage, and we have the number of moose observed. So part A, the researchers who are conducting the study expect the number of moose observed in a habitat type to be proportional to the amount of acreage of that type of habitat. Are the data consistent with this expectation? Conduct an appropriate statistical test to support your conclusion. Assume the conditions for inference were met. Well, that's nice. Okay. So, notice we have counts of the number of moose. There are 117 moose in total. What we could do then is compare this to the expected number of moose in each one. We would just take the proportion of total acreage times the number of moose observed. So I'm going to add an extra column, expected number of moose. Now, if you want to be efficient, then you probably want to, on the NumWorks, go ahead and start doing, what kind of a test is it that we're going to do here? Okay, first of all, it's not chi,
Chi?
it's chi-squared. Which one? Ruin a nail?
Carl is not doing good today.
It's those cheap pencils you keep buying.
I know.
I think I can make it.
So which of the chi-squared tests is it? There are 3.
What's 3? I remember.
There are 3.
Cuteness of fit or oh yeah, because homogeneity and independence are 2 different ones.
Right. Although
They
the,
both
the nuts and bolts of it is the same.
Right. I think we'll do a homogeneity test.
no one.
I guess now I know the answer.
Independence.
There we go.
Oh. Goodness of it.
Yes, because we're comparing what actually happened to some idealized, we think it should be this many, right?
Say that again, please.
We're going to compare the number of moose observed in each of those regions to, they think it should be proportional to the amount of acreage.
Okay, so
Is it really proportional to the amount of acreage?
we're trying to see if it fits.
So, for the TI, you would enter this into L1, and then in L2, you would do the 0.340 times 117.
Mr. Davis,
Yes?
wasn't there a way we could plug it in and then it would give us the expected values?
It's not going to give you the expected values. You're going to have to type 0.340 times 117.
Wait, what if you don't get a whole number? Because it's like
You're not going to get a whole number.
Oh.
We're absolutely happy with non-whole numbers.
Yes. Oh, so we need to do the calculations first, obviously.
Well, and you can do those within the test on the NumWorks. No, go into NumWorks, go into inference, go into the chi-squared test for goodness of fit.
Oh, I gotta back up. Inference, test, chi-square, goodness of fit,
Right?
observed, put these in, and then expected, put in.
Yeah,
The equation.
yeah,
Okay.
and it'll calculate those for you.
We don't do total, right?
No, you do not put in total.
So why again? I always forget. I understand the proportion of each acreage you multiply it, but why wouldn't you multiply it by 25, like, or 22 or something?
Because it's a proportion of the total moose. 25 is how many we saw.
Yeah.
What we want to know is how many do we expect to see?
Yes, that makes sense. Do we round to the nearest whole number because it's moose?
Nope.
Oh, really?
No, the expected number, remember when we did the dice thing? We rolled a dice 100 times. How many times do we expect it to come out to be a 1? 16 and 2/3,
That's not possible. Okay.
right? What we expect sometimes is not possible, right? So that's partly why I dislike the word expected. It's like, I don't know what would be a better word, but so what are these numbers?
39.78.
So there's a lot fewer in that area than we expected.
11.82.
So there's a lot more than we expected in this one,
12.17. And
and
then
a lot more of that one, and then
53.24.
53.24, so less for that one. I'm just noting that at this point. All right, so do the chi-square test for goodness of fit.
Okay. I got it. And degrees of freedom is 3 times 2. Is that how you do it?
Nope, there's 3 degrees of freedom.
It gives you, it makes them.
Oh, it always does that? It always gives it to you?
Yes, but even if it didn't, you should know there are 4 categories, right? It's just 4 minus 1.
Oh, what was I thinking?
You're thinking about when you've got a two-way table. And this is not a two-way table.
So we need to do our hypothesis first?
Yep, we need to do all that kind of stuff. I'm going to enter these into mine. You could be thinking about what the hypothesis should be.
This one where we always write it out.
I think so, yeah.
Just that chapter.
Yeah, you're going to have to write out.
It's not
So,
much.
what is our null hypothesis?
That our expected is equal to our observed.
I'm sorry?
Our expected number of moves are equal to the observed number of moves.
So, but you have to be a little more specific about that. And what did they say here? They expect the number of moose observed in a habitat to be proportional to the amount of acreage in that type of habitat.
So we say that verbatim.
Yeah, that's our null hypothesis.
So we just say we expect?
Yeah, well, you just say the number. Of moose observed in a habitat type to be proportional or is proportional to the acreage in that type of habitat. What's our alternative? Do you guys remember how we did this?
Is not proportional.
We would say at least one of the groups, in at least one of the habitat types, the number of moose observed is not proportional to the acreage.
Or will we say, or
Would we say what?
the difference, but that would make sense.
Okay. So in at least one habitat type, the number of moose observed is not proportional to the acreage. We'll set our alpha level at 0.05 because I don't see any reason not to. The degrees of freedom is 3. Oh, I guess I should write that this is a chi-square test or a chi-square goodness of fit test. And it gives us that chi-squared is 43.67. And our p-value is basically 0. So, what do we do?
Reject the null.
Yeah, we reject the null. And conclude that the number of moose in a habitat area is not proportional to the total acreage.
could you also just be like, we reject the null and conclude, and then just like copy and paste the alternate, and at least.
Yeah, you could.
For this problem, do we now need to say that we found convincing evidence to conclude?
You don't have to. I usually do that when they say, when they say, "Is there convincing evidence?" I usually parrot what they say. All right. Then, relative to the proportion of total acreage, which habitat types did the moose seem to prefer?
The fourth one, because it's the most.
No, not close.
Oh, you have to compare it to the.
We expected 53.24 in that one,
Yeah.
but we only have 40.
So you have to find the difference.
It's the one that's closest to the actual observed.
Well, it says habitat types, so that says to me that it could be more than one. And which ones did we have more moose than we expected?
2 and 3.
2 and 3.
A lot more.
Double.
So in habitat types 2 and 3, because in each of these there were more moose than expected.
So I'm curious, if we were to like say only habitat 2 or only habitat 3, would we get partial credit on the.
Oh, we'll look at that in just a moment.
Okay.
All right. Another way to look at this would be to look at the chi-squared contribution for each type.
Duh.
Oh yeah, wow.
If we look at the contributions,
Oh, there is a lot.
you can see that 3 and 4 have the greatest contribution.
I mean 2 and 3.
I mean, 2 and 3, and 3 has way more than anything else.
Yeah.
Quite a hefty amount of contribution.
All right, let's look at
Okay.
how they wrote it up.
All part 1? Oh my gosh.
Pardon?
This whole page is like scored from part A, and the second one's all part B.
Well, not all of the second page, but yeah, the whole first. This is why I don't grade AP stat exams. I don't ever want to do these because, and this is not a long one.
Yeah.
Oh my gosh.
So you could have just said for your hypotheses, your null could have been moose have no preference for habitat type. I'm like, okay. We kind of did the second one.
Yeah.
The number of moose in each habitat type is proportional to the amount of acreage in that habitat type. And the alternative, the number of moose in at least one habitat type is not proportional to the amount of acreage in that habitat type.
So is each step a point or no? Do you have to get all the
Well, it'll show that in just a second. Or you could have said the proportion of 1 was blah, 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 where piece of 1 is the proportion of moose in habitat 1, etc. And at least one of those is incorrect. So that's one thing you have to do. You have to write the null hypothesis and the alternative. Step 2 identifies the correct test either by name or by formula. We did it by name. It's a chi-square goodness of fit test. Okay? Step 3, the correct mechanics, including the value of the test statistic, degrees of freedom, and the p-value, or the rejection region. Basically, we just need to tell them that the degrees of freedom was 3, which we did. Tell them the chi-squared statistic was 43 point whatever, and that the p-value is incredibly low. So then states a correct conclusion. The data are not consistent with the researcher's expectation. Because the p-value is less than 0.05, we reject the null. There is strong evidence that the moose have a preference for habitat type. So you can see that. Now, for part B, there were two different ways that you could do this. The moose seemed to prefer habitat types 2 and 3 relative to the portion of total acreage. A higher proportion of moose were observed in each of those. That's what we did at first. You can say here, habitat type 3 seems to be the most prefers. It has a positive difference between the observed and expected counts of moose and the largest contribution to the chi-square statistic. Or you could say habitat 3 has the largest positive difference between the observed proportion of moose and the expected proportion of moose. Notice you can't say, and this is where students get into trouble, that it has the largest positive difference in just absolute numbers. Because if it has a large difference, but the expected is quite large, then the contribution is going to be pretty small still. Remember, the contribution is the observed minus expected squared divided by the observed. So if you expect 3,000 and there's 3,050 and that's the biggest difference, well, you know, if the other ones, they were 40 different, but they only expected 100 in each one of them, that's going to be a bigger contribution. So that's why I usually stay away from that way of saying it, because you're oversimplifying it. Just because there were more, you know, the gap was greater doesn't necessarily mean it's got the highest contribution.
So if we're going to talk about difference, we need to mention contribution.
I would just talk about the contribution, yeah.
So from those three, what do you think would be like the best?
The easiest thing I think on this one was to do what they did first.
Okay.
Because in both of those, there were more moose in that area than we expected.
So hypothetically, if we were to do the second one, would we have to state the numbers like 30, 12.26, and the chi-square value?
It would probably be good to talk about the fact that, you know, it has the largest chi-square. Notice here, it just did one type.
Yeah,
It just did type 3.
that makes sense.
Okay? All right. So here is a different problem. So product advertisers studied the effects of television ads on children's choices for 2 new stacks. The advertisers use 2 30-second television ads in an experiment. One ad was for a new sugary snack called Cocoa Zooties, and the other was for a new healthy snack called Apple Zooties. For the experiment, 75 children were randomly assigned to one of 3 groups, A, B, or C. Each child individually watched a 30-minute television program that was interrupted for 5 minutes of advertising. The advertising was the same for each group with the following exceptions. The advertising for Group A included the Choco Zooties ad, but not the Apple Zooties ad. The advertising for Group B included the Apple Zooties ad, but not the Choco Zooties ad. And the advertising for Group C included neither the Cocoa Zooties nor the Apple Zooties ad. Which to me, when I read that, I immediately thought, oh, that's kind of a control group.
Yeah.
Right? You didn't show those either ad. After the program, the children were offered a choice between 2 snacks. The table below summarizes their choices. All right. So on this one, it says, do the data provide convincing statistical evidence that there is an association? Anytime you see this thing about an association, that's going to be a chi-square test for independence.
Independence is the one where it's like the same population as two separate groups, right?
No, two separate groups is homogeneity.
Oh, wait.
We don't have two separate groups here. So, we have, here, let's look at this. God bless you. Oh, I'm sorry. I apologize. This is homogeneity. Someday I'm going to get homogeneity and independence completely straight in my head. Apparently it's not today.
So association means homogeneity?
It's more about your groups, I think, is the easiest way to do it. So independence, you have one group and each individual in that group has two different characteristics. The one in your book talks about tattoo status and hepatitis, right? So they took a group of people and they looked at their tattoo status and their whether they had hepatitis or not.
Each person.
Right. So each person has two different things.
Ah, okay. Whereas this one where it's like we have still people but they're separated.
Right. We separated them into three groups.
Yes, that makes sense.
So we're checking for homogeneity here. All right. So do the data provide convincing statistical evidence that there is an association between type of ad and the children's choice of snack among all children who participated in the experiment. To save us some time, because I do want to look at the quizzes. So you have to start with a pair of hypotheses. The proportion of children who would choose each snack is the same regardless of which type of ad is viewed. Right? There is no difference. Whereas the alternative, the proportion of children who would choose each snack differs based on which type of ad is viewed. Okay? So this is a chi-squared test for homogeneity. Now, with those, we're going to enter them in.
So this is the one where you do every individual one?
Yes, but not the totals.
Yeah.
This is what I was talking about when I gave you the expected values earlier.
Yes. And Ariel, I said I'd forgotten about the expected values thing. When you perform the test on the TI, if you go back to matrices, there's one at the end that will give you expected. Here, let me show you. So we have to go into matrix. This is 3 rows, 2 columns. So I need to go over here and edit this. So we've got 21, 13, 22. And then 4, 12, 3.
Oh, you put 1 instead of 12.
I'm sorry, thank you. Okay. So when you go to stat test, you come down to a chi-square test. It's going to put the expected in matrix B all on its own. You don't have to figure out the expected. So once you've done this and you calculate it, and you have all this information, if you go back to the matrix, oops, stop. Seeing how there's now one in B? And if you go into that one, it'll show you all the expected values.
I bet she knows.
Okay.
Yeah.
All right. So it turns out that the chi-squared number here and it's 2 degrees of freedom because it was,
ABC.
right, well, no, it's ABC, and you have 2 columns and 3 rows. This is one where it's number of columns minus 1 times the number of rows minus 1. So this has 2 degrees of freedom. And the p-value is 0.006. So a very low p-value. So because the p-value is very small, we reject the null hypothesis, and the data provide convincing statistical evidence that the proportions who would choose each snack differ based on which ad is viewed. The interesting part on this one actually comes in part B. Write a few sentences describing the effect of each ad on each children's choice of snack. When neither ad was viewed, 88% of the children chose Choco Zooties, whereas 12% chose Apple Zooties. This is where it cracks me up. When the Cocoa Zooties ad was viewed, 84% of the children chose Choco Zooties. The Choco Zootie ad actually made them less likely to pick Choco Zooties.
What?
That's really weird.
That's crazy.
Apparently they didn't like the ad.
So where would we be seeing all this so that we could write that, something like that? Is that in contributions or where's that at?
You're just looking at percentages.
But where,
You do.
where would we find?
You do the percentage.
I have to find them?
Man.
Mr. Davis, you give me everything else. Why
It's
can't
just
I give
22
you
divided by 25.
what?
Like, on the chart. If you're looking at people who chose chocolate Zooties
Oh, 'cause
in
I'm looking
group
at the
C, you
total.
just do 22 divided by 25.
21?
If
Oh.
you're, if you're
Oh,
looking
because 22 is that's where they weren't viewed, or they didn't view either. Oh, okay. Oh, okay. So that's not that bad. I was overreacting, Mr. Davis.
Okay.
I'm sorry.
he does that a lot.
So notice they didn't do this in terms of contributions. Can we look at contributions and get anything useful?
Let's see.
Mm.
Dun, 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 dun.
So I haven't had mine do the test yet.
Oh, I'm sorry. That was really loud. Are you making it?
All right, so
The Apple Zooties and who chose the Apple Zooties are the biggest.
yeah, unfortunately, the contribution doesn't tell you a whole lot except that, the biggest contributions were in Group B, which is the one that watched the Apple Zooties ad.
Yes.
But to tell whether the Apple Zooties ad helped or not, the contribution doesn't tell you, because it doesn't tell you if the expected is higher than the actual,
Correct.
or whether what actually happened is more or less than the expected.
Okay, yeah. Because you're always gonna be positive, right?
Right. So I probably wouldn't have done it this way. I probably would have, on the chart, gone, okay, so in Group A, which was the Choco Zooties, hang on a second. Expected counts are seen in the. I thought it was 22 out of 25.
For neither, yeah. 22, they watched chocolate zooties, chose chocolate zooties out of the total 25. But that's why I was confused.
All right, hang on just a second. Oh, this was when neither ad was viewed.
Yeah.
They did this. I'm like, I would have gone in the same order. So for part A, they
So what have you done?
in Group A, they watched the Choco Zooties ad.
So 21 divided by 25, right? To find those who watched chocolate zooties and chose chocolate zooties.
Right. So it was close to the expected. Right? So when they watched the Choco Zooties ad, the number who chose Choco Zooties was close to the expected number, both for how many picked Apple Zooties and how many picked Choco Zooties. For the ones who watched the Apple Zooties ad, way more than expected chose Apple Zooties.
For watching the Apple Zooties ad.
Right. And fewer chose the Choco Zooties. So the Apple Zooties ad was quite effective.
Yes, because more chose.
Right. And when you watched neither,
You could talk about either one.
yeah.
Because of how it was.
And so again, the interesting thing is if you watched neither, 22 chose Choco Zooties. If you watched the Choco Zooties ad, only 21 of them picked it. So you can talk about that, or you can talk about, like here, if you didn't watch either, only 3 chose Apple Zooties. But if they watched the Apple Zooties ad, 12 of them chose Apple Zooties. So that's a big difference.
Yeah.
So you can talk about it being different from the expected, which is what I would have done, or talk about it the way that they did.
That makes
Either one is fine.
okey-doke.
That's part of what makes grading these so difficult, is there's frequently more than one right way to approach the problem. All right.